Okay, so this is going to be our Algebra 2 Unit 3 Day 1 video. And in it, all we're really going to do is refresh on some basic nonlinear concepts relative to quadratics. Uh, Not going to review on linear concepts in this video just because the do now for this lesson really hits on uh, linear concepts we've studied previously that we're going to need to know for this unit. So I digress. Let's get to it. So first thing we want to look at is going to be, well, we've got a quadratic function here. Obviously, it's nonlinear. First thing we're going to do is just refresh on how to utilize formulas, namely what number one is asking us for, the vertex of this function, right? And remember, every parabola has a vertex, right? So this is what we're looking for here when we're using this formula. It would have been faster if I just erased it. Okay, so let's go ahead and calculate that. So all we're going to do, if you remember, when we're written in standard form, we have A, B, C. All we're going to do is plug in A and B where they go here in this little formula. So to find our x coordinate for our vertex, we're going to put negative b divided by 2a. So let's go ahead and do that. So negative b divided by 2 times a, right, by f of that. And we'll review what that means here in a second. Okay, so negative 4 over 2 times 2. So that just is going to become negative 4 over positive 4, which of course is just negative 1. Right, so that means our x coordinate for our vertex is just going to be at negative 1. Okay, and to calculate our y coordinate, right, our y coordinate, this guy here, well, we're going to have to find f of that. So that means we're going to do f of this number that we just found. So f of negative 1. Well, f of negative 1 just means we're going to replace x, every instance of x, with negative 1. So 2 times x squared plus 4 times x minus 6. That, of course, is going to give us, so negative 1 squared is just 1. 1 times 2 is 2. 4 times negative 1 is negative 4. So 2 minus 4 minus 6. Okay, so 2 minus 4, that's negative 2. And then minus 6, negative 8. So that means our vertex is at negative 1 by negative 8. Okay, simple enough. Okay, so let me erase this, give myself some room to make the following calculations. Okay, so next thing it's asking us to do on number 2 is to calculate f of negative 3, f of 0, and f of 1. Okay, well, let's see what that looks like. So first, let's start with f of negative 3. So that's just 2 times negative 3 squared plus 4 times negative 3 minus 6. Negative 3 squared is 9. 9 times 2 is 18. Minus 4 times negative 3, which is 12, so minus 12, right? Well, plus negative 12, so minus 12. And then negative 6 is still just negative 6. Then we just combine things. So 18 minus 12 is 6. And then we have that minus 6 still there, which of course gives us 0. So f of negative 3 is equal to 0. Okay, now let's do the math to find f of 0. That one's going to be pretty quick. And again, that just means replace every instance of x with 0. So instead of f of x, we have f of 0. So f of 0 is going to be 2 times 0 squared plus 4 times 0 minus 6. 0 squared times 2, well, that's going to be 0. 4 times 0, 0 minus 6. Of course, we see that f of 0 is going to be negative 6. Okay, and now we're looking for f of 1. Okay, so f of 1 is going to also be pretty simple. Let me just work smart here and not hard. Put ones. Okay, so 1 squared is 1. 1 times 2 is 2. Plus 4 times 1, which is 4, minus 6. 6 minus 6 is also 0. So we have f of 1 equals 0. Okay, pretty interesting. Weird little thing going on there. We'll figure out what that means, well, when we get to that point. So calculate f of x's y-intercept. Okay, so remember, if I've got some function, who cares what it looks like? Let's say f of x looked like this. It doesn't. It's a parabola, but let's just pretend. The y-intercept is right here where we touch or cross the y-axis, right? So where does that happen? Well, the y-intercept happens at x equals 0, always. Okay, so the y-intercept happens at x equals 0. That means it happens at f of 0. That's where x equals 0. Well, we already calculated that. F of 0 is negative 6. So that means my y-intercept is negative 6. Okay, now it's asking us for the x-intercept. Okay, and let me switch to a different color here. So I'll use orange. So x-intercepts, again, let's just use some arbitrary nonsensical drawing. Oh God, that's a horrible looking arrow. Okay, so let's say f of x looked like this, right? Okay, so right here, this is analogous to what we just saw. Our x-intercepts are where our function crosses or touches the x-axis. Well, in this case, it happens 1, 2 times, right? Those would be my x-intercepts. Where did they happen? Well, they both happen where y equals 0. Okay, so that just means I set the function equal to 0. Okay, so when we do that, instead of f of x equals our function of x, right, we're going to say 0 equals 2x squared plus 4x minus 6. Okay, and we're prompted here also to find it 3 different ways using the quadratic formula, AC grouping, and completing the square. Okay, so what we're going to do first is the quadratic formula. Again, we refer back to the fact that we are in standard form, right? So A is 2, B is 4, C is 6. Okay, so what is the quadratic formula? Well, you probably have forgotten it with your Christmas brain. Okay, the quadratic formula just basically says we can solve any quadratic equation that's written in standard form using this formula here, negative b plus or minus the square root of b squared minus 4ac. Remember, this in here is our determinant, all over 2 times a. So all we're going to do is plug those numbers in, so a, b, c, into this formula here. Okay, so that's going to become negative b plus or minus the square root of b squared, so negative 4 squared would be 16, minus 4 times a times c, all over 2 times a. Okay, and we can just start simplifying. So what we really have, negative 4 plus or minus. So negative 4 times 2 is negative 8. Negative 8 times negative 6, brain fart, is going to be positive 48. So we've really got 16 plus 48, all of that, over 2 times 2, which is 4. Well, 16 plus 48 is going to just be 64. I like how it just didn't switch to the eraser like I selected. That's amazing. But 16 plus 48 is going to give us just 64. Okay, the square root of which, so now we've got negative 4 plus or minus, the square root is 64, so plus or minus 8 over 4. So that gives us our 2 x-intercepts. Okay, negative 4 plus 8 would be positive 4. 4 over 4 is 1. okay? And negative 4 minus 8 would be negative 12 over 4 is negative 3. Okay, so what that means is uh, our parabola touches the x-axis at positive 1 and negative 3. So our parabola is going to look, if we draw some symmetry here, our parabola would look something like this. Okay, hopefully it looks a lot less crappy whenever you guys try to draw it. Okay, so we did it with the quadratic formula. Okay, so kind of arduous there, right? Simple, tedious calculations. Okay, so now what we're going to do, we're going to come to the exact same conclusion using a different method to solve this exact same equation here. So using AC grouping, remember we've got a process, so we multiply A times C. So that gives us negative 12. And we consider the factors of negative 12 such that they would combine to give us B, which is positive 4. So the factors of negative 12 that combine to give us positive 4 would simply be 6 and 2, and more specifically 6 and negative 2, right? So next step, so 6 times negative 2. So 6 times negative 2 gives us the negative 12. 6 combines with negative 2 to give us the positive 4x. Our next step is to split bx into these two factors. Okay, so all that's going to come down to is rewriting. So 2x squared, instead of plus 4x, we have plus 6x minus 2x. And then, of course, we still have the minus 6 sitting there. Now, our last step, well, our last couple steps is just to group and factor several times, right? So we group just by using parentheses here. Okay, here in this left term, we see that we have a GCF of 2x. When I factor out the 2x, that leaves me with x plus 3. Okay, over here, we see that we have a GCF of negative 2. So I'm going to factor out a negative 2, and we're left with x plus 3 again. Okay, so that means this factors out into 2x minus 2 times x plus 3, right? And we're still equal to 0. Okay, and we see that we can easily solve this now just using the zero product principle. So we set each one individually equal to 0. So this parenthesis bubble here gives me my solution of negative 3, because if I say x plus 3 equals 0, right, well, of course, one-step equation to solve that. Okay, this right here is going to give me my positive 1, because if I set that equal to 0, 2x minus 2 equals 0, I'm going to add 2, divide by 2, and of course, x is equal to 1. Okay, so did AC grouping. Right, and there's some tricks we could have used that would have made that go even faster. Okay, and last thing, oh, I don't know why I erased that. I will need to erase this. Last thing is by completing the square, and this is going to go even faster than the other two methods. You guys are just afraid of completing the square, though, for some reason. Okay, so we're going to complete the square, so that means we're plugging into this formula. So when we've got x squared plus bx, we can factor that into a perfect square of x plus half of b all squared minus b over 2 all squared itself. Okay, so this is what we're going to look for, right? So we're looking here. This is our x squared plus bx. The problem is we have an a here, and here we don't have an a, right? So what we need to do is factor out that 2 from this so that it becomes 2 times x squared plus 2x now. And then we still have the minus 6 sitting there. So 2x squared divided by 2 gave us the x squared. 4x divided by 2 gave us the 2x. Okay? And now this here looks just like this. which means we can refactor it, rework it into looking this way and easily solve our equation. Okay, so x plus half of b all squared plus, whoops, not plus, minus half of b, again, all squared itself. And that's kind of redundant. What's 1 squared? So that's just going to be 1. So minus 1. And we can't forget we still have the 2 and the minus 6 sitting out there. We're going to redistribute the 2 back inside so that we can solve this for x. So that's going to become 2 times x plus 1 all squared minus 2 minus 6 equals 0. Okay, these two combine to give us a minus 8. Then I can add 8 and then divide by 2. And remember, we always work from the outside in. Okay, so x plus 1 all squared equals 4. And I ran out of room here. Okay, then I'm just going to get rid of this exponent of 2 by doing its inverse, which is to take the square root or the second root. So that gives us x plus 1 is equal to, and anytime you take a square root, you have a positive and a negative solution. So the square root of 4 is 2, so plus or minus the square root of 4, so plus or minus 2. And then our two solutions give us negative 1 plus or minus 2. Negative 1 plus negative 2 will give us negative 3. Negative 1 minus 2, right? Negative 1 minus 2, or negative 1 plus 2 gave us the 1. I'm stupid. Negative 1 plus 2, here, let me back up. Negative 1 plus 2, right? That gives us the positive 1. Whoopsie, brain fart. Negative 1 minus 2, that gives us the negative 3. Okay, so found our y-intercepts using 3 different methods. Okay, and then now all we have left to do is sketching our graph. Okay, so we have all of our key points now. Okay, so what we need to focus on is the key points. So we know our vertex is right over here at negative 1 by negative 8. We know our x-intercepts. Our x-intercepts are at negative 3 and positive 1, right? And of course, we know our y-intercept is right there at negative 6. Okay, so let's translate that onto here. I'll use green, that'll show up the best. So I remember that the y-intercept was at negative 6. What do you call it? The vertex, let's see here, give myself some room, was at negative 1 by negative 8. So there's the y-intercept of 0 by negative 6. That's the y-intercept. This is my vertex of negative 1 by negative 8. Okay, one of the y-intercepts was at positive 1. So that means we are at 1 by 0. And the other y-intercept was at negative 3. So that means we are at negative 3 by 0. So this is one x-intercept. There's another x-intercept. Okay, and we've got 4 very clear points that we can use to kind of sketch our graph here. And let's see if we have any other points we can use. I don't think I gave us one. No. I wanted to be like pragmatic about where the x and y intercepts come from. So basically you take those points and you already know parabolas have that vertical line of symmetry, right? And you just connect those points with a smooth curve and there you have it. Okay, so that concludes this video. Again, all this was to review concepts that we should already have down, but like I said, we're working off the Christmas rust. Goodbye.